Hey everyone, thanks for tuning in. This is Jeff speaking, and today we're talking about Azure Storage Service Encryption. Say that 5 times fast, I dare you. I'm going to fail several times throughout this recording. It was a dark and stormy night, and I'm not kidding about that either. My power is flickering on and off right now. I'm lucky I have batteries on stuff, and hopefully we'll get through this. We've got about 15 minutes to talk about storage service encryption, so without further ado, let's dive in. All right, encryption. It's a big, darn big deal, right? All right, data life cycle. It has to be encrypted throughout these days. There is so much theft and threat of theft out there, and so much penalty now. The penalty for loss of patient health information is something absurd, like $250,000 per incident, and a database full of patient information could be hundreds or thousands or millions of incidents. If you think about it, that means bankruptcy any way you look at it. So storage service encryption is how Microsoft is demonstrating some of their commitment to safeguarding data. They introduced this last year, and it came out as optional. I'm doing air quotes, optional, but as it's matured over the last 10 months, it's really starting to look like not optional. Let's look a little bit closer. Real quickly, storage service encryption uses 256-bit AES standard. That's the advanced encryption standard. There's more information out there on Wikipedia. Let's just say that AES is the standard, has been since about 2001. Storage service encryption is not the same as disk encryption. You can actually encrypt your VM disks inside your storage service encryption domain, for lack of a better word, and basically have double encryption. That also means double overhead, so you really have to decide whether that's the thing you want to do. It is also not the same as rights management. Rights management follows the file wherever it goes. It assumes that there's some mechanism by which you can authenticate to a rights management service and actually have access to the contents of the file. Storage service encryption is literally encryption for data at rest. Here's a pretty picture showing what data at rest encryption looks like in this context. We're putting all of the overhead, all of the processing is on the server side. It's operating inside Microsoft Cloud Service. They're taking on the burden and putting their resources towards making your experience as fast as possible, even knowing that you're 256-bit AES encryption. All right, so SSE, where can you do it? You can do it on standard disks, you can do it on premium disks. Premium disks, basically those SSDs that we talk about when we're looking around in the Portal GUI. If you want faster throughput, faster I/O, you go with solid state, costs a little bit more. You can encrypt that, all right? Standard is basically your spinning platters, you can encrypt that. Microsoft says you can use this for file storage and blob storage. Those are the allocation tables and the big unstructured data sets like images and video. Back in August of 2017, Microsoft also implied that it was going to work for tables and queues, and we'll look more at that here in a minute. VM disks that are created inside an existing managed storage service, if that service is encrypted, those VM disks will also be encrypted by default, but not the disk encryption, just the storage service encryption. So if we were to stand up a new Ubuntu server, for example, it would come online with storage service encryption, but the VM disks would not necessarily be encrypted until we then went in and enabled it. All levels of Azure redundancy support encryption, so whether you're doing local redundancy or across the globe redundancy, you have encryption. It doesn't matter what region you're in the globe, you have encryption available, and it looks like it's mandatory now. There's a quick note that at the time of release there were instructions on how to toggle it, and the blade for toggling it still exists in the Azure portal. However, we'll demonstrate that doesn't seem to really mean anything. At the time also, when you were enabling storage service encryption, you were only encrypting net new files on existing storage. If you had old data sitting there, it would not be encrypted until you actually rewrote it. And that is a true get and put. As far as we understand, we were not able to demonstrate that at all anywhere because we don't have any of that old storage. There is mention that SSE is only available for Resource Manager storage accounts. So what are we talking about? Because Resource Manager is what's in the Azure portal, right? That's what's in the Azure CLI. This is what we use. there is a thing out there called classic storage, and if you go in through the portal and try to create storage manually, you will see that this option still exists there. It is the old way. It's still interactive with RESTful APIs, but does not support CLI or PowerShell. If you have some of this old storage, it was possible for it to interoperate with Resource Manager storage, but if you wanted to convert Classic, you need to start over. There's no conversion mechanism. Back in that same bulletin in 2017, I have a link for it in this presentation towards the end, but in that same bulletin, Microsoft insinuated that Classic would also be encrypted by SSE, but I haven't seen any way to prove that, as I don't have a way to instantiate any Classic storage. We didn't use Classic in Deep Dive, but it's still out there. Like I said, it's still on those blades. You can look at it. I tried standing up new through the CLI. I tried using templates, and nothing I did worked, so I skipped Classic storage. There's some continuous improvement notes. June was when the storage service released, June of 2017, and there was a note in there, that release notice, that managed disks will have encryption enabled by default. There is still such a thing as unmanaged disks. If you want to build a new server using a VM template, you can say unmanaged disk, and it takes away some of Microsoft's ability to do balancing and data protection on that. But if you want to make that choice, you can. August is when we start talking about tables and queues data being included in SSE. I haven't found any evidence of that actually happening. Also in August, the preview, quote-unquote preview, was made available, and you can still request access to this preview. You have to send SSE preview an email and ask for access to it, at which point you supposedly get some toggles on your blades, and potentially you have some commands available to you in the CLI. One of the questions that popped up is, how do I actually manage my keys all by myself? And if I retire a key, is my data encryption rotated to the new key automatically, or do I have to go through all this data, decrypt and re-encrypt with a new key before I vault that new key? Wouldn't that be a pain in the butt? So you could extrapolate from that. If you were to unpack this and not have SSE as a solution, if you were going to do this yourself, you would have to have your security policies all figured out. You'd have to create the artifacts that drive this, your keys and your key vaults, etc. Your development teams would have to know how to interact with the artifacts and write them into the code and interact with the vaults. And you would have to have some kind of auditing in place, right? This is just sort of normal process. Well, SSE sort of takes all of that overhead off of you, off of your staff, off of your salaries, and I haven't seen much of an audit trail, but the other parts of that are all taken off. SSE works seamlessly by itself in the background. And at no cost. Microsoft introduced this as no additional cost to customers, which was very nice of them. I did include a note here about processing overhead. Presumably there's some cost in terms of I/O and just the amount of hardware it takes to encrypt and decrypt everybody's stuff all the time. Well, Microsoft seems to have put a pretty hefty amount of resources into this, because as far as I can tell, the encryption and decryption process works very, very quickly. Now, I haven't tested it against terabytes of data, nor am I going to, but I encourage you to. Some of the references I mentioned in my talk there are shown on the screen. Those are available for anyone. Do note that if you click on that Managed Disk Encryption link and try to get it to connect, that sometimes that hash sign there in the middle is interpreted as something like %20-%20. It doesn't interpret very well. You have to fix it in your browser and then it'll work. But that is a legitimate link. All right, let's jump real quickly into more practical examples, and we can look at this stuff. All right, so let's just look at storage. Here's a server that I created. This is an Ubuntu headless server with simple disk setup, and I just want to look at how the storage for this server was configured. Right? This was just done using the default setup from from Microsoft Azure. And I gotta remember which resource group this is in. This resource group. Here we go. Here's our disk. 949 is the germane disk here. And if we look at properties, it's not going to tell us what we want to know. There's nothing here about encryption. Alright, let's see. Here we go. Alright, your virtual hard disks are actually stored as a blob, so they are within the blob service. When we look at blob encryption, it is enabled. Alright, let's see. Can I disable this? No, I cannot. Look at that. It failed. We'll pop that back open. Look at that. You can see I've made some past attempts here as well. Here's the new attempt. It failed. Alright, so I have to discard that, and I can go back to my dashboard. Alright, this is true even with storage that I just created on my own. If I drill down and look at some of these storage services, let's go back to the resource groups. I created some storage just by myself. I created some blob storage, and here's the event hub. Here's the storage account. It's fine. Here we go. Blob encryption. It is enabled. I try to disable it. Save. Boom. Same failure. Look at that. I am not turning this off without, I don't know, calling somebody. Turning it off is not possible. Okay, so, well, let's talk about how this actually interacts with our software. And by talk about, I mean let's look at. What I have here is some code left over from homework 9, which was about event hubs. And let's just take a quick peek. I've stuck this out on my local machine, a couple of Python scripts. Nothing really fancy. It's all code that's out of public domain out there under educational license, I believe it is. I won't dig into what the code actually is. It's available in my GitHub if you want to take a look at it. I'm just going to execute this homework 15 sender script, and what this is going to do is it's actually, I'm not going to do it that way though. It's actually just going to send some bogus environmental data, just randomly generated environmental data placeholders to the event hub in Azure that we just looked at just recently, this one that is actually encrypted. And the second script that's in here will process some of that data. So there we go. There should be some data out here for us to look at. I pinned this to my dashboard so we can be quick about it. Just look. Here's the hub folder. Yeah, here's some subfolders, 2018, February, and all kinds of stuff in here. An Avro file, you might remember us looking at that. Now, if we look at the properties of an Avro file, there is not much to see. There's nothing here that talks about it being encrypted. We can actually look at the Avro file contents, and it says, I don't know what this is, so it might not render right, but there's data here, and it's readable, so it's been decrypted, at least into the portal screen to an extent. So we can look at it. Alright, that's cool. And let's jump back to our other script. And let's run it. Alright, what this has done now, if we just load the directory again, you can see it created all these comma-separated values. It has requested the event hub process these in some fashion. And we'll grab one. We'll refresh this real quick, make sure I'm not lying to anybody here. We'll put these here so you can compare the directory names. We've got just a homework 15 directory, local homework 15. We'll just take the top one and have a look at it. Well, there it is, readable data. Well, like I said, this is just all programmatically generated numbers. They're not meaningful to anyone in any way, but they're here and I can look at them. And they exist in the cloud as well. So, Merry Christmas. There's your encrypted data. It's been decrypted and expressly written to my machine, and it remains, a copy of it remains here in the cloud, and it is encrypted. So that's storage service encryption in a nutshell. It sits behind everything. The overhead is handled by Azure, and you can feel relatively confident that your data all has 256-bit AES wrappers around it, and nobody's going to hack your stuff. Thanks for watching this quickly done tutorial. I appreciate it, and we'll catch you next time.